Hey guys, how's it going? It's Mr. Dorado here with another video for you guys. And today we are talking about section 3.4, which deals with parallel and perpendicular lines. So that is our objective today, to continue talking a little bit about how we can write linear equations, but now we have a few special cases which are these parallel and perpendicular lines. So let's go ahead and take a look at parallel lines first. And let's see if we can go ahead and identify something about their slopes. Okay, so let's go ahead and calculate the slope for this red line here. So I'm going to start just like we always do with a point that is on the left, and we're going to go to a point that's on the right. Okay, so let's go ahead and find out what our slope is. So remember, slope is rise over run. So I'm going to go ahead and go up 3. So I went up 3, and then I go to the right 4. Okay, now just remember, you can use any 2 points. So if you wanted to, you could have actually chosen this point and this point, and you really should be getting the same answer. But let's verify. 1, 2, 3, rise. 1, 2, 3, 4, run. So yes, you do still get 3/4. Okay, so just a little bit of a refresher from previous sections. Now let's go ahead and calculate my slope for my black line. So I'm going to start here from the left and go to this point here on the right. So once again, I'm actually going to go up 1, 2, 3, and then to the right 4, so a positive 4. So I have my two slopes here for my red and for my black. I want you guys to take a quick look at those two slopes and tell me what you notice about them. Okay, so hopefully what you notice is that these parallel lines have the same slope. Okay, hopefully you guys noticed that right off the bat. Those two actually have the same slope, and that's actually something that you'll soon understand is always the case. Parallel lines always have the same slope. Now when you get further into maybe algebra 2 or geometry, you will actually get more understanding of why that's true. Okay, because the reason why we want similar slopes in parallel lines is because they have the property that they will never touch each other. In order to do that, they need to be going at the same rate of change. But that's for another class, for another time. All we need to know now is that parallel lines just have same slope. Okay, so let's go ahead and compare it to perpendicular lines and see what we can identify from those. So let's go ahead and calculate my slope for this red line here. So I'm going to start on the left point and go to the right point, and that right point is actually lower, so I'm going to have to go down to the right 5, so a positive 5, so negative 2/5 for my slope on the red line. And then for the slope on the black line, I'm going to use these 2 points, and remember, you can use any 2 points you want, but I always like to choose the points for this on the left. So I have to go up 1, 2, 3, 4, 5, and run 1, 2. So rise of 5, run of 2. So even before I write what I noticed here as a full sentence, let's go ahead and think about what we noticed here, guys. Okay? So go ahead and take a second and see if you can figure out what those two slopes have in common, or why they're different, or how they're different, what similarities do they have, anything you notice about them. Okay? Alright, so if you have looked at these quite a bit now, you'll notice that actually one of them here is a negative, and although there is no symbol here, what do we know is the symbol there if there is no negative there? Then we know it has to be a positive. So what's true about those two slopes? Well, one of them is negative, one of them is positive, meaning that they have opposite slopes. Okay, one of them negative, one of them positive. Now look at the numbers. What do you notice about the numbers? For the first one, you have 2/5, and the second one, you have 5/2. It looks like they just flipped, right? Okay, so that's another property of perpendicular lines. They're opposite, but they're also reciprocals of one another. Oops, totally misspelled that. Let me go ahead and rewrite that. Reciprocals. And if I do butcher any of these spellings, guys, I'm sorry. That's why I'm a math major. So we have opposite and reciprocal, so let's go ahead and write down what we notice. We notice that perpendicular lines have opposite and reciprocal slopes. Okay, perpendicular lines have opposite and reciprocal slopes. And I knew this was spelled wrong, so let me fix that. So perpendicular lines have opposite and reciprocal slopes, and that actually we're going to go ahead and fill out down here as well. So parallel lines have the same slope, and perpendicular lines have slopes that are opposite and reciprocals. My spelling is horrible today. Of each other. Okay, so they're opposite and reciprocals of each other. So let's go ahead and keep that in mind when we do the next set of problems. So I'll go ahead and keep those that little text box up there for us so we can use it if we need it. So this example number 1 asks, write a slope-intercept equation of a line that passes through the point 2, 6 and is perpendicular to the line y equals -1/2 x plus 4. So let's go ahead and break this down first off, okay? What do we want our final answer in, by the way? We want it in slope-intercept form, so we want it in this. I'm just going to go ahead and write that as a reminder to make sure that my answer actually is in that form, okay? But this is the key word that I want us to focus on right now because that's something we just talked about. That's the whole lesson for today. Perpendicular. What does it mean? Well, we want a line that's perpendicular to this line right here, y equals -1/2 x plus 4. Well, that line already right here is in slope-intercept form, right? Okay, that's in slope-intercept form, so I should be able to identify that slope right now. The slope right here is -1. But remember, I'm trying to write a new equation for a new line that passes through this point, okay? So I was given a point. Now, because I already know that the original slope was -1/2 for this line, I want something that's perpendicular to it, so I need to write a new slope, and it has to be, remember, opposite and reciprocal of the original slope. So the opposite of a negative is a positive, so it's definitely going to be a positive. And also the reciprocal, which means just flipping the 1 and the 2, means it's going to be a 2 over 1, which just reduces to a 2. Okay, so we have all we need now. Remember, this is basically just a review from last time now. We have a slope, okay, and we have a point. So we have a slope and a point, meaning I can write a point slope equation, okay? That's not what I want the answer in the very end, but at least that's what I can go ahead and start writing now. So let's go ahead and write a point slope equation. Remember, it has to be of this form. Y minus y1 equals m, x minus x1. Now, we no longer need this slope, whoops. We no longer need that slope, we need our new slope, which is this one right here. Okay, so let's go ahead and write my equation. So it's y minus my x1, y1 over here. So my x1 is a 6. My new slope is a 2. Then x minus my x1 is another 2. Well, that's a point slope equation, but I don't want a point slope equation. I need a slope intercept, so I have to distribute. So let's go ahead and see what we get. We have y minus 6 equals 2x minus 4. Last step here, add 6 to both sides. We get a final answer of y equals 2x plus 2. Okay, so now this is of that form, which is exactly what we needed. And if you compare the two lines now, the original one I had and this new one that I have, they have opposite and reciprocal slopes, meaning that the lines have to be perpendicular. So we have satisfied our problem, okay? We have satisfied what we were asked to do. So let's go ahead and try number 2 so we can get a better understanding of what we just did, okay? Now, let's see right away what we were given. So we want an equation at the very end that is in slope-intercept form. So again, if you want, write yourself a little reminder here so you remember what form it has to be in the very end. Now, it says we want a slope-intercept equation of a line that is parallel to y equals 2x plus 11 that passes through the point -3, -5. So the first thing I want to tackle here is this word. Remember, this is one of our new vocabulary terms, which means that I have to have the same slope. Okay, so if the original slope here was 2, then what does my new slope have to be? Well, parallel lines have similar slopes. They have the same slopes, so my new slope is 2. So it's also 2, okay? So what information do I really have? Well, I have a point, this x1, y1 here. So I have a point, and I have a new slope. So the information that I have so far is a point and a slope, so I can go ahead and write a point slope equation, kind of like what I had up here, okay? So let's go ahead and write one in that form. I have y minus y1. In this case, y1 is a -5, so it's actually going to be the opposite of a -5, which means a +5. My m is 2. And then x minus a -3, so the opposite of a -3 is a +3. Okay, that's good and all, but we want something in slope-intercept form, so we have to distribute. So let's go ahead and distribute this out. Okay, so what do we get? We get y plus 5 equals 2x plus 6. We have to get rid of our 5 so we can isolate the y. And we get a final answer of y equals 2x plus 1. So this is my final answer here. Now we compare these two. So compare your two final answers, or not your two final answers, your one final answer with the original equation, which was this one right here. And do they have the same slopes? Yep, the coefficient in front of the x is 2 for both of them, and hence they have the same slope. Good. So hopefully you guys have a little bit of a better understanding now on how that works. So let's go ahead and do a few practice problems. Okay, I'm going to do 1 and 2 with you guys, and then I want you guys to go ahead and try out 3 and 4. So let's go ahead and see what information we're given. It says write a slope-intercept equation. So if you want, go ahead and write yourself a little reminder here. That's the final form I need to be in. Okay. Of the line parallel to this line, -5x minus 3, and has a y-intercept of -6. So, again, parallel. Parallel means I have to have the same slope as that. So my original slope was -5. My new slope that I need has to be the same because it's parallel so it's also -5. Okay, so my slope is -5, and I was actually given a y-intercept, so it's kind of nice because that's already my b. So I have everything I need to go ahead and write my slope-intercept for. So my b here is a -6. So I have an m, I have a b. So in y equals mx plus b, all I'm doing is substituting those values in. So I get y equals -5x minus 6. And that is in this form, so we are good to go. So that one was pretty painless. Okay, let's try out number 2. Again, what do we want our final answer in? Slope-intercept. So let's write ourselves a reminder. Make sure we're at that answer at the very end. What other information are we given? So we want something that passes through the point 2, -5 and is perpendicular to this equation. Okay, so perpendicular meaning we have to have opposite and reciprocal slopes. So opposite and reciprocal slopes to what? Well, to this. This is my original m 2/3, because remember this is already in slope-intercept form, guys. So you can identify your slope right away. It's just the coefficient. Okay. Now, whoops, my new m, which I'm going to write here in red, has to be what? Well, my new m has to be opposite and reciprocal of that 2/3. So opposite of a positive 2/3 is definitely a negative, and the reciprocal of 2/3 is just 3/2. So my new slope here is -3/2. Okay, so I have a slope, and I actually also have a point, this x1, y1 right here. So I can go ahead and write a point slope equation. So let's go ahead and write it down. So y minus a -1, which is a +1, equals my slope x minus my x1, which is 2, so -2. We're not done because it's not of the form that we need, so we have to distribute. We get y plus 1 equals -3/2 x plus, because the negative times the negative is a positive, and then that multiplies to be 3. Last step here, let's subtract the 1, so we get y equals -3/2 x plus 2. So let's compare both of our equations here. 2/3 x minus 1 and -3/2 x plus 2. All that really matters is the slopes, that those will tell us if we have a perpendicular line, as was asked. And it is true, they are perpendicular, because 2/3 is the opposite reciprocal of -3/2. Okay, and these two were of the right form, so we are done. Okay, I think I'm gonna have you guys try 3 and 4, and we will come back to try out 5 and 6 together. So go ahead and try 3 and 4, pause the video, and try those out. Alright guys, let's go ahead and try out number 3. So what's being asked? Write a slope-intercept equation. So y equals mx plus b of a line that is parallel to this line, y equals -2/3 x plus 7. So I know it has to be parallel, and hence it has to have the same slope. So if my original slope is this one, -2/3, then my new slope, my new m, has to be the same, -2/3. Okay? Now, that's all the information I was given. I wasn't given any points. I wasn't given a y-intercept. All we were given is that it has to be parallel to that line. Well, let's think about it. Remember what this is right here, guys. This is a y-intercept, okay? So this line goes through that y-intercept at at 0, comma 7. Well, if we want a new line that is just parallel, we can choose whatever y-intercept we want. We definitely don't want to choose the same number. We don't want to choose 7 again, because that would be two lines that are exactly on top of each other, which defies the point of being parallel. Okay? We want something that has the same slope, but a different y-intercept to make sure that they never touch each other. So you literally can go ahead and choose whatever number you want. I'm going to choose for my b, for my y-intercept, okay, remember this is like your b, I'm going to choose something like 5. Simple enough. So let's go ahead and write an equation for it. I have y equals my new slope, which is negative 2/3, plus 5. And let's see if that satisfies what we need. Does it look like that? Yes. And do we have same slopes? Yes, we do. And we have different y-intercepts, but that's totally fine, because if I were to graph those, they would just look like they're kind of one right above the other, and they would never touch each other. So again, although you weren't given that information, guys, we can start to process and understand what it means to be parallel. The biggest thing is that it has to have the same slope, and it has to have a different y-intercept, okay, than the original equation. Alright, good. Let's go ahead and try out number 4 and see how you guys did there. And guys, remember, I'm having you guys try these out on your own before we actually look at them. That's just so you guys explore and actually try these out to see how well you do. If you don't get it right the first time, that's the whole point of me going back and doing them with you. That way you guys can understand what you were thinking originally and how that changed now that we went over it. Okay, so don't worry if your answers were wrong originally. Okay, let's go ahead and try out number 4. Let's write a slope-intercept equation. Okay, so slope-intercept equation. I know that's in y equals mx plus b form of a line that is perpendicular to y equals negative 5x minus 10. So perpendicular, I know it has to be opposite and reciprocal. But what is the original slope I have? It's negative 5, meaning my new slope has to be an opposite reciprocal slope. Well, let's think about that. Well, first off, we know that the original one was negative, so the new one has to be a positive, okay? Now, the original one was just a negative 5. It wasn't even a fraction, so we can't really do the reciprocal yet. But remember, we can always put that original slope over 1. So now if I flip them, if I do the reciprocal, my new slope, instead of 5 over 1, it's going to be 1 over 5. So it's going to be a positive 1 over 5. Okay, positive 1/5. Okay, so once again, I have now a a opposite and reciprocal slope. And just like number 3, we weren't given any other piece of information, so we can choose again whatever y-intercept we want. So let's go ahead and just pick one. Let's pick, I don't know, b equals, well, let's pick 5 again, just like we did in the previous problem. So let's go ahead and write a slope-intercept equation. We have y equals 1/5 x plus 5. Okay. Are these two slopes opposite reciprocals? Yes, they are. And is this of that form already? Yes, it is. So we are done. Okay, good. So let's go ahead and try a few more together, and then I'm going to have you guys try out these last few on your own. So let's take a quick look here. So it says determine if the lines are parallel or perpendicular. Okay, so as we know, the thing that tells us whether they're parallel or perpendicular are their slopes. So I want to take a look at this equation first. First off, can you identify the slope just by looking at that? Okay. Now, if you said yes, I'd like to know how you did that, because I can't do it. Okay. Now, if I work it around a little bit, then I can identify it, but it's not in slope-intercept form. If you guys remember, this right here is actually in standard form. So in order to identify the slope, I'm actually going to go ahead and isolate the y, and rewrite it in slope-intercept form. So let's go ahead and do a little bit of rewriting here. So what I'm going to do is get rid of the 2x because I want to get the y by itself. So I get 3y equals 2x minus 3. Divide everything by 3. I get y equals 2/3 x minus 1, and this is my rewritten equation. Okay? So what is my slope in this equation? Well, it's m equals 2/3. So I'm just going to go ahead and write that off on the side. And look at that. On this other equation, okay, this one over here, that's already in slope-intercept form. So we can identify the slope right away, which is 2/3. So my slope here is 2/3. Now we can tell whether it's perpendicular or parallel. Okay, and if we notice, the two slopes are exactly the same, meaning this has to be parallel. Both of those lines are parallel. Okay, so this is your final answer right here. Okay, let's take a look at the next one. This one right here, it's asking to see if we can determine if it's parallel or perpendicular, and once again, double check the form that your particular equation is on. This one is in slope-intercept form, so I can identify my slope right away. My slope here is 3/5. Okay, that was easy, but the next one is not in slope-intercept form. It's in standard form again, and we know how to solve that. All we have to do is isolate the y, solve for y. So I'm going to add 5x here, 5x there, so I get 3y equals 5x plus 6. Divide everything by 3. I get y equals 5/3 x plus 2. Okay, so that's my new equation. Let's go ahead and write down my slope for this one. Well, what is my slope? It's right here in the very front, which is 5/3. Okay, now we can tell right away that those are definitely not the same. So they are definitely not parallel. And they are reciprocals of one another, so it looks like they might be perpendicular. However, aren't they both positive here? There's no symbol here, so this definitely is a positive. There's no symbol here, so it's definitely a positive as well. So although they are reciprocals, they're not opposites, meaning it cannot be perpendicular. So the only answer here is that neither. They're neither parallel or perpendicular. Okay? Alright, let's go ahead and continue with number 7 and 8 so you guys can try some of your own. So write a slope-intercept equation. So, and again, guys, if you get good at this, you don't have to keep writing yourself reminders like this. I do to always make sure I am double checking my work and have the correct answer. Okay, so let's go ahead and see what else we're given. So find the slope-intercept equation of a line that passes through the point -8, 5 with a slope of 1/2. Okay, well, write a slope-intercept equation of a line that passes through the point -8, 5 with a slope of 1/2. It did not mention anywhere on there that we have to write a perpendicular or a parallel line. Okay, so all we're being asked to do is go ahead and write something in slope-intercept form that goes through that point and has that slope. So I'm going to go ahead and name this my x1, y1. So what do we have? A point and a slope. So I can't go straight to slope-intercept, but I can write my point slope form. If you guys remember it, again, you don't have to keep rewriting this, but if it helps, go for it. So I have y minus y1 here is a 5. My slope is 1/2. X minus a -8 is the same as a +8. Not the form I want, so I have to distribute. So what do I get? I get y minus 5 equals 1/2 x plus 4 want to isolate the y, so I'm going to add 5 to both sides. So I get finally y equals 1/2 x plus 9. Okay, I'm actually going to rewrite it up here. Equals 1/2 x plus 9. Is that in slope-intercept form like I wanted? Yes, it is. So I have my equation of a line. Okay? Take a look at number 8. It says write a slope-intercept equation. So y equals mx plus b of a line that passes through the points -3, 3, -2, and 6, 0. So I was not given a slope, I was not given a y-intercept, all I was given was points. But we know that if we are given 2 points, we can go ahead and call these x1, y1, x2, y2, okay, and calculate your slope. So actually, while I go ahead and grab my charger, go ahead and pause the video for a second and try these out.